In this video presentation, we will show you how to calculate the deflection of a beam. You will soon see that it is a relatively long process to find the deflection of just one particular beam. As there are many beams in a single structure, to save time, the engineer will use a computer program. However, the maths this program does must be understood. Steel and concrete beams undergo testing to determine their allowable deflection and lifetime performance. Here is an example of what can happen if deflection of a beam is not correctly calculated and the beam is overloaded. Our structural engineering firm is working on the design of a new building. As part of this structural analysis, we must determine the deflection of the beams to ensure they are within the tolerated amount. To do this analysis, we will be using numerical integration. Beam curvature can be calculated using the formula seen here, where E and I are constants and bending moments, m, can be expressed in terms of x, a distance from a support. We can differentiate the curvature equation twice to get an equation for deflection, v. One of the beams to be analysed in this building is a simply supported beam spanning 6 meters, which is subject to a uniformly distributed load of 20 kilonewtons per meter. Let us calculate the deflection for this beam. We first need to determine the reaction forces, which end up to be 60 kilonewtons at each support. Now we know all the forces acting on the beam, we can write an equation for m. Now we have an equation for m, the curvature equation can be integrated. As E and I are constants, they can be taken out the front and we integrate m. This introduces a constant, c. The equation is then integrated a second time, which introduces a second constant, d. C and d must be calculated using boundary conditions. As the beam cannot deflect at the supports, we have our first boundary condition. Also, as the beam is symmetrical about the x and y axis, we have a second boundary condition. Evaluating these boundary conditions, we find d is equal to 0 and c is equal to negative 180. We now have an expression for v, which can be used to find deflection at any point, or to find the location of maximum deflection. We are going to see if a universal beam, which has the values of I and E, seen here, will support the load with tolerable deflection. As the beam is symmetrical, maximum deflection will occur at mid-span. These values are subbed into the expression for V, and a maximum deflection of 3.5 millimeters is calculated. This deflection is within the tolerated amount. Therefore, this universal beam can safely be used to support the load.